Okay, with this lesson, we're looking at horizontal transformation. So we're doing our sine and cosine and tan graphs. Now we've already done the movement, the vertical movement. So that's the vertical where you just move, pretty much the zero line moves up. And then you just go up and down the amplitude. And we know that this number, the number in front of the angle, will affect the period, so how quick it turns. Now we're going to do these ones, this extra bit, and this is going to move the graph left or right, so it's horizontal transformation. So if you look at this first question, sketch 3 sine theta minus pi on 2 for one cycle. So if you have a look, that 3 is the amplitude. And if you look, there's a 1 here. So if you look at the period was 2 pi over 1, which is why we got 2 pi. And we found the intervals by dividing the period by 4. So I've got the period is, the intervals is pi on 2 there. Now, so what I think the best way to do is, before we do this movement here, this left and right movement, you should sketch the original graph without the movement. So what I'm going to do is I'm going to sketch 3 sine theta like normal. All right, so we saw that it should happen on pi on 2. So you can see I've done pi on 2 is the intervals, so it's a positive graph, and so I'm going to go through all the intervals. Okay, now, whatever. So if you see that, this is what the graph would have originally looked like without the left and right movement. So now what happens is this will move, and because it's negative, it moves the graph to the right, pi on 2. So if you look, all these green dots original will move over pi on 2. So you can see that became the first dot. Now there would have been because the sine graph would have continued, there would have been that dot down here as well. So you got to remember that's moved over as well. So here's my first dot, and you notice they're all moving, all the green dots are moving over, and you can see there and move there over, so all your main points. So if they want me just to do one full cycle, so if I'm going to start here and I go up, down, around, and I could keep going, and there we go. So it's the blue graph is the answer. So if you've just sketched your light one in grey lead, then we can take it off and you're left with your answer. So you can see, maybe moving across. So you can see sometimes we're going to have to change that to a fraction that looks like our interval, and we might see that on the next one. So let's do, just to go over to the amplitude. So we've gone up to, that would be 3, and that would be -3. All right. So if we do this other one here, so the amplitude is square root 3. So you can see I have drawn those 2 lines in up there. I've worked out the period is pi, and so the intervals are that divided by 4. So I have popped in my intervals. So I've got pi on 4, that would be pi on 2, 3 pi, and so on. Okay, now, so I know the normal graph, so it would go through pi, so normal one, I'm drawing the normal one in green without the movement. And if I went backwards, it would look like that. Okay, so what we are now doing, we need to move every point over pi on 2. So these points are going to move, and they're going to move to the left because it's positive. So we're going to move left. Now, if you notice, pi on 2 could be written as 2 pi on 4 because my intervals are pi on 4. So when you've got to move, you actually got to move it 2 intervals over, because pi on 2 is actually 2 pi on 4. So you're going to see these move 2 intervals. So if you look, this dot is going to go over 2 intervals. So you go 1, 2, and there's that dot. Okay, and if you look at this dot, is going to move 2, so it'll be 1, 2. So it became here. I'll do a solid dot. Okay, so this one will move 1, 2 intervals over, solid dot. This dot here moved over 2, 1, 2. This one here moved over 2, so 1, 2. So you can see your graph is changing, and that one there would have moved over 1, 2, so there it is. Okay, so you can now see if we start, go through all those solid dots, you see that it moved over like that. So I'll just rub out the green one. And the green one, rubbing out the green one, and the red one is the answer. So you can see how you've moved and so on. They get a bit tricky, just got to take your time and do it. And obviously there's the amplitude, so we're amplituding at 3 and negative square root 3. Okay, with this last example, I'm going to draw the one without the movement in red. So I'm just going to draw 2 cos 3 theta first in red. So we can see we've calculated the period to be 2 pi on 3, and we've also calculated the interval to be 2 pi on 12. Okay, so if you look, here's the basic one. So I know it goes like that, and that would be, this line here would be 2 pi on 3. And you're essentially going up like that's like pi on 6 or 2 pi, yeah? And that one is like 4 pi on 12 and so on. Okay, so you can see that through there. Okay, we need to move though this graph the left. We need to move it left pi on 4. Now because we wrote these little intervals as 12, so I'll leave that one as 2 pi on 12. Let's make this interval as 12. So it means 3 pi on 12. So all these points here, we're going to minus 3 pi on 12. So if you look, 2 pi on 3 would be like saying 8 pi on 12, yeah? So if you're going to minus 3 pi on that, this dot is going to go, I've moved it back here, but it essentially is going to be 8 pi. This one's 8 pi on 12 minus 3 pi on 12. So this one's now 5 pi on 12. So that point is what that is. Okay, so you've moved that one. Now if you went to move this one, which is the original point is 6 pi on 12, or pi on 2. So that one's got to be, if we're moving it, we're going to say 6 pi on 12 minus 3 pi on 12, which is going to be 3 pi 12. Okay, so it's moved 3, that'll be wherever that is. So 3 pi on 12 a little bit here, yeah? So we've moved that point to there. And you can see where you get the green line. You've got to do that for all the points.